start. All right, today we're going to learn about a thing called polynomials. We're going to start off just giving you some definitions real quick, and then we're going to get right into the problems. Okay, these should be pretty familiar to you. This is kind of, I think you did this in Algebra 1, and you definitely, when you got into Algebra 2, you should have seen a lot of this kind of thing. All right, so let's take a look at what a polynomial is. And basically, it's just, this is not a real mathematical definition or anything. Let me pull this down. It's basically how many terms you have in an expression. So for instance, let's start off with the first one. Let's talk about a monomial. Monomial. So polynomial, what is the prefix poly?
Many.
Many, very good. Okay, the nomials just means how many terms you have. Okay, we're going to talk about terms right now. What about the prefix mono? How many? It's one. Okay, so basically you just have one term. All right, and I'll show you what I'm talking about here in a sec when I mean one term. So they get really, really descriptive about these What's that?
Mono. I know mono means one.
Right, that's what we just said. Mono right there, and the prefix mono means one, so one term. All right, so they get really specific. I wrote down a lot of real specific notes, but I'm not going to get quite as specific as they do because I want to get to the problems. Okay, I want to teach you guys how to do these problems. So let's just take a look at some monomials. So for instance, if I have like 5a or 6ax squared, that would be considered a monomial. And you're like, well, wait a minute, I got 1, 2, 3, 4 different things here. How's that a monomial? Well, really, these terms, when I talked about a polynomial is just many terms, the terms are basically broken up in between like pluses and minuses. So if I had this plus something else, then I would have two monomials. All right, but this is just one monomial. There's no plus sign or minus sign in here. You could put a negative in front of there, but that's not really considered as being added or subtracted. So that would be a monomial. You could have all kinds of crazy looking things. You could have something that looks like this. That would be a monomial, okay? Because it's not being added to something else. It's not being subtracted from something else. That's a monomial. If you had just the number, just a whole number, okay, just any number. It could be a negative number. It could be a positive number. That's considered a monomial. That's good enough, okay? They give some more examples in the book. If you want to look in the book and see the other examples, feel free to do that, okay? That's a monomial. And they go through some stuff. Again, I'm not going to hit everything that they talked about right here because that's really not the crux of the matter here. I just want to be able to define terms and see what we're doing here. So a monomial is one term. What if you had a binomial? It's pretty easy. What's the prefix bi? It's two. Okay, so you basically have two terms. So really, if you have two monomials either being added or subtracted to each other, that would be considered a binomial. All right, and then what do you think the next one is? It's a trinomial. Okay, and how many is that? Pretty easy. Tri means three. All right, so you have three terms. Now, when you go above three terms, they quit giving it a special name, all right, like monomial, binomial, trinomial. They'll just call it a polynomial. All right, and that's really all I need to show you. So let's do a binomial. I'm just going to make this up. So what if you had like 3x plus 2y? That would be considered a binomial because this would be one term, this would be a second term. It's separated by a plus sign, or it could be a minus sign if you wanted to, and that would be a binomial because there's two terms. All right, so what if you had something like this? What if you had 5x cubed y minus 2x squared plus 1? All right, so if you had something like this, how many terms do we have? We have three terms because the terms are all being separated by a minus or a plus. Everybody see that? So there's one term, there's another one, and there's another one right there. There's three of them, so that would be called a trinomial. And that's really all I need you to know about that. Again, they get a little bit more specific. Some math teachers would say, oh, you didn't go far enough. You didn't give some specifics about, because there are some things about exponents, if it's a polynomial or not. You can look in the book and see that. I'm not going to, when I like blow by this stuff and say, well, it's really not that important to me, You're not going to see that on a quiz or a test, all right? So I probably won't even have this. I probably won't even ask you, is this a binomial? There are some questions in the homework, but I didn't even give you those questions to do in the homework, all right, on if this is a binomial, if it's a polynomial, if it's a trinomial, all that kind of stuff. I just want to be able to just look at something and you be able to tell me, oh, that's a binomial or that's a trinomial, because we're going to use those terms, fairly often. So I just want to make sure that you guys know where we're coming from on this. All right. So enough of that. Let's do some problems. All right. So what we're going to do is we're going to add polynomials. And basically, the phrase that we use all the time is that you can only add, let's put this, you can only add like terms. You've heard that before, haven't you? Okay, so you can only add like terms. What in the world does that mean? Oops, why did I put that S so small? Okay, you can only add like terms. For instance, let's put a few terms in here. I'm going to make this up before I do the actual example. So what if I had this? What if I had, I'll just make it super easy. 2a plus 5b minus 3a plus b. All right, what if I asked you to add these polynomials? I don't know, when you were in pre-algebra, algebra 1, you can only add apples to each other. You can only add oranges to each other. I don't know if people said that or not. But anyway, that's what this is. Pretend this is the A is for apples and the B is for bananas. You can only add the apples together. You can only add the bananas together. Does it make sense? All right, so you can't add the apples to the bananas. And people say, well, but they're fruit. Yeah, they are, but you get the idea. You can only add the like terms, the things that are the same. So what are our like terms here with this 2a? Is there anything else in here that is the same term as 2a? What do you think? The 3, right, the 3a. Even though it's got a different number in front of it, that number in front of it we call the coefficient. Probably could have said that. Coefficient. All right, so that number out in front that's being multiplied by the variable, we call that the coefficient. I'm just going to get rid of that just because I need more room. Thank you. All right, so what we're going to do is we're just going to add the like terms. You can do this in your head if you wanted to, but I'm just going to write it down so you can see what we're doing. We're doing baby steps here. I mean, some of you guys are like, oh my gosh, Mr. Hammer, we've done this forever. Since I was in 7th grade, we did this stuff. All right, I get it, I understand, but not everybody's in that same situation. So we're going to start from scratch. So what I'm going to do is add up all the like terms. So I got a 2a right here. What's the other like term? The 3a. But what's in front of it? A minus sign. So we put minus 3a. So I'm done with that one, done with that one. Let's find my other like terms. I got a positive 5b or plus 5b. I'm going to put that right here. And then I'm going to add it to this like term, which is a plus b. All right. What's the coefficient of b if you don't actually see it? It's a 1, right? It's a 1b. All right, everybody with me on this? Again, I understand you might not have to do this, and that's perfectly fine. If I gave you this problem, you can just do this in your head and write down the answer in this situation. But I'm going to do this. So we have 2a minus 3a. So 2 apples minus 3 apples. What you do is you just keep the term the same and just add the coefficients. So what's 2 minus 3? It's negative 1a. Everybody with me on that? So I added the like terms. You can only add like terms. And then I can add the a's, and then I can add the b's. So I'm going to add the b's together. It's a positive 5b plus a 1b. It's a plus 6b. You could leave it like that, and that would be fine. You could circle it, and you get full credit for it. No big deal. But what would make this just a little bit nicer? And just get rid of the what? The 1. We don't really need the 1 there. So we could just write negative a plus 6b, and that would be our answer. If you wanted to, I don't know why you'd want to, but if you wanted to, you could change the order. You could call it 6b what? Minus a. All right, either one of these would be acceptable, and it's perfectly fine. Everybody with me on that? All right, that was real baby stuff. Let's do one that's a little bit tougher. So this is the first example, and this is, did I write it down? I didn't even write down what example. I guess it's example 1 in the book. I don't even know. But I'm just going to put EX for example. I didn't write down the example. So here it is. I'm going to write it out. You're writing this down? Even though it's in the book, it's a good idea to write it down. Because if you have the experience of doing this on your own, instead of just sitting there and watching me blab on and on, it's going to make it a lot better for you. 3x to the 4th minus 2x cubed plus x squared. This is the problem that never ends. There it is. All right, that's a plus x. It's kind of weird looking, but all right, so here we go. What we need to do is we need to add like terms. It'll say to add. Okay, and so we're going to add them all together. So we can only add the things that have the same term. So let's go through. You see some exponents right here? What I like to do, you don't have to, but it kind of is nice and it just looks a lot better. I like to start with the highest power exponents first. So which one has the highest power exponent? The x to the fourth right here. Do I have any other terms in here with x to the fourth in it? No, I don't. Okay, so that's my only one. So I'm just going to write 3x to the fourth. And when you got a whole bunch of these things, this is helpful to me sometimes. If you got a whole bunch of them in a row, just mark it off so you know you're done with it. All right, because sometimes you accidentally, add things together that you should have crossed out. All right, what's the next highest power? It's the cubed, isn't it? Let's do that one next. Okay, so I got an x cubed here. Let's keep looking, up right here. I got an x cubed right there. So those are my like terms. I don't have any other x cubes. I just got those two right there. So again, we just add the coefficients and just stick the term in with it. So it's just 8 and then a minus. We got a minus in front of that 2. So it's 8 minus 2, which is 6. It's a positive 6. So what sign are we going to put here? Plus. Right, positive. So 6, and then what's our term? It's 6x what? Cubed. Pretty easy. I'm done with that one. I'm done with that one. We've done this before, right? Sure. What's the next highest power? X squared. So I got an x squared here and I got an x squared here. Let's add those up. I got a negative 2 plus what? What's in front of this? It's a 1. What's negative 2 plus 1? It's negative 1. Do I need the 1? Not really. And I can just put negative x squared. So I'm done with that one. I'm done with that one. I kind of like marking them off, right? So I know how many I have left. It's kind of nice. I mean, you might be able to do it in your head. That's fine. All right, let's do, what's the next one? Well, I got an x to the first. I got an x here, and I got one x right there. Add those up. Positive 6 plus 1 is positive 7x. I'm done with that one. What else do we have? Just a regular number, regular whole number, right? That's the only one I have, isn't it? I got a negative 2. I can't add it to anything else, so I just put minus 2. That crazy looking thing right there is the answer, and I circle it. That's all there is to it. Questions? It's pretty easy, isn't it? Yeah, absolutely. All right, let's do one where we subtract. Another example, EX. So now we are going to subtract, and let me show you what that looks like. They put a parentheses here. Just because you have a parentheses, a lot of people think that means multiplication right away. Sometimes it does, but in this situation it does not. So it's 4x cubed plus 6x squared minus 1. That's in parentheses, and then you got a minus, then you got another parentheses. This is where the subtraction comes in. So we got one little extra step to do with subtraction that we didn't have to do with addition. Minus 6x plus 5. All right, there we go. Let's change this to yellow, have a little contrast here. Everybody wrote that down? Now look at the parentheses on this first one. Is anything being multiplied by this first parentheses right here? No, there's nothing out front here, is there? Do you really even need the parentheses? Not really. Okay, you're not distributing anything. There's nothing being multiplied by it, so you don't really need it. So what I'm going to do is I'm just going to rewrite this without the parentheses. But on the second one, where the parentheses are, do you need the parentheses on this one? Absolutely, because of this minus right there. You're not just subtracting the 2x fourth. What are you subtracting? The whole thing, right? Everything inside of here, okay? You're subtracting. If you want to, you don't have to do this, but I'll just do it so you can see it visually. You're subtracting that one, you're subtracting this, and you're subtracting this, and you're subtracting that. Kind of made a mess of it, but that's what we're doing. You're basically distributing a negative through that parentheses, right? You've learned that in Algebra 1, Algebra 2, about distributing numbers through. So what we're doing is we're just taking the opposite sign of everything that's in here. So this was a positive 2x to the fourth, but you're subtracting it, so it's going to be a minus 2x to the fourth. This was negative 8x squared, but what's a minus a minus? It's a plus, right? So it's a positive. You're just changing the sign because a negative basically just means it's the opposite of something. So it's plus 8x squared. I think this step is really important. I would not try to do this whole thing in your head. I would write this step, the one that I'm writing right now. I think that's very, very important. Then the next one's going to be a plus 6x, and the next one's going to be a minus 5. You see why? I just changed the sign. That's what this thing right there means. It means you just change the sign of every term that's in there. So I made that negative, positive, positive, negative. And now I can do what I did earlier. Now it becomes an addition problem. So let's just do it real quick. X to the fourths. I got this one and I got this one. I got 3 minus 2, which is just 1 x to the fourth. Cancel that out. Check my math, make sure I'm doing this right. The next one is x cubed. I don't see any other x cubes except for this one. So I'm just going to write minus 4x cubed. The next one is x squared. So I got a positive 6 and a positive 8. What's that? 14. So plus 14x squared. It's easy to add like terms, isn't it? You just add the number that's out in front, the coefficient, and then you just slap on the term right next to it. Let's do the x next. Do I see any other x's? Nope, that's the only one. So I put plus 6x. I'm done with that one. And then I got regular numbers, okay, whole numbers or integers. I got negative 1, minus 5. Negative 1 minus 5. Do you remember the rule? You add the opposite. So you change that to a plus, change that to minus. What do we get? Negative 6. So I'm done with that one, done with that one. I've added up all the like terms. I can't add those any further than that. That's my answer. Piece of cake. With me? Yeah. You're probably wishing it got harder, don't you? No? Well, my goodness. I thought you would. Nah, of course you don't. So now what are we going to do you think? We added, we subtracted. What do you think the next thing is? Multiply. Multiplying. Did I spell that right? Multiplying polynomials. All right, so start right off with an example. You've seen stuff like this before. X squared minus x. Again, this is right in your book, this example. So now you're multiplying this stuff together. I tell you what, let's start off with a little easier one first, like a super easy one. Like that, okay? That's really easy. That's Algebra 1 easy. So if I was going to multiply these things together, first of all, I always look to see if I can add like terms inside the parentheses. Can I add like terms right here? No, because there's no like terms. I can't add those together. So the only thing I can do is, what's the word we use? It's distribute, right? I think I even said it a little earlier. So we distribute the 3, which means we multiply everything inside the parentheses by a 3. So it's 3 times x squared, which is just 3x squared. And then you put a plus sign because it's both positive. And then 3 times x is just 3x, and that would be your answer right there. So that's how you would multiply that. This is kind of the same thing. Let's change it. Except you have 2 things over here being multiplied by 3 things over here. All right? It's kind of the same thing. What you're going to do is you're going to take the first term and multiply it through everything in the second parentheses. All right? And then you're going to take the second term and multiply it by everything in the parentheses. And then you're back to adding polynomials again. All right? Everybody see what I just did? I took everything in the first parentheses and multiplied it by everything in the second parentheses. That's what multiplication of polynomials basically is. It's the big old distributive property. There's 6 things we're multiplying through here. So let's do this pretty quick. I only have a few minutes left. So we got 2x times x squared. Well, do you remember how to multiply x times x squared? We learned this, right? You even took a quiz on it, didn't you? What do we do with the exponents? It's a 1 right there. We add the exponents. So that would be x cubed. All right? So this is what this is going to be. So it's multiply the coefficients first. 2 times 1 is just 2. Let me give it some room. And then x times x squared is x cubed. So I'm done with that first one. Now I do this one. I got a minus. and then a 2, and then an x squared, because x times x is x squared. I'm going quick, so just write this down. Try to follow along. So now we do the 2x times the last term right here. So it's 2x times 2. Multiply the 2 and the 2 together. They're both positive, so we put a plus, and it's just 4x. So that's multiplying everything by 2x. Now we multiply everything by this 5. So I take this 5 and I multiply it by everything through here. So it's positive 5 times x squared, which is just positive or plus 5x squared. Then we take the 5 and multiply it by the second one. And it's just a negative 1x times 5, which is just negative 5x. And then we do the last ones, okay? The 5 times the 2. They're both positive. So when we multiply two positives, we get a positive. 5 times 2 is 10. Now, do we just circle it and we're done? We're done all the multiplication, but what should you always look for? Like what? Like terms. So let's take a look to see if we have any like terms. Let's start with the biggest one first, the x cubed. Do we have any other x cubes? Nope. So I just write 2x cubed. And I like to get rid of it. I like to mark it off. The next ones would be x squared. Let's see all the x squareds we have. We got this one here, and we got this one here. So I got negative 2 plus 5. Negative 2 plus 5 is positive 3, so I put a plus, and my term is x squared. Remember, you don't add the exponents when you're adding like terms. You just keep the term the same and just add the coefficients. I'm done with that one. I'm done with that one. What else do we have? We got some x's. I got a positive 4 and a minus 5. 4 minus 5 is negative 1. Do you need the 1? Not really. X. So that's 4 minus 5 is negative 1x. If you want to put the 1 there, you can. It's not that big of a deal. And then what else do we have? We marked off everything else. The only thing we have left is the positive 10. So we put a plus 10, and that's it. Pretty simple, I think. I don't know. Maybe because I'm the teacher, maybe. I don't know. That's not too bad, is it? Just take everything inside of here, multiply it by everything inside of here. Add up all your like terms, bang, you're done. We call this descending order. Do you see how I put it from the highest power down to the lowest power? We call that descending order, from the highest to the lowest. Do you have to do that? You don't, okay? I could have put the 10 first if I wanted to. I could have put the negative x first if I wanted to. But this is much, much nicer. This is what I would prefer, okay? You write it as, all right? And most teachers would. All right, well, let me give you some problems to do. This is section R4, and it's page 48, and it's 27 to 45, and again, always, I don't know if I'd say always, but most of the time it's always the odds, okay? That's your homework right there. Everybody see that? So page 48, it's 27 to 45, the odds. You can look on RenWeb. I've got it on there, okay? You could go back. If you didn't write it down today, I don't know why you wouldn't, but if you didn't, you can go back to YouTube, look at it, and you're good to go. But let me just stop the recording, and I'll bring that back. All right, have that finished we don't have class tomorrow, so have that finished for Wednesday. All right, so you get 2 days to do this. By the way, we are going to have another quiz on, let's see, when did I put that? I think it's Thursday. Let me double check. It's on that geometry stuff. Yep, Thursday. So let me write that down so you can't say I didn't tell you. All right, so quiz on Thursday, and it's on R.4, which is the geometry. Go back, look at the YouTube videos. If you didn't understand something, come and ask me if you need any help with that. So quiz on Thursday, and it's 10 questions again, and that will be on geometry. All right, that's it.